Let's say we have the trinomial x squared plus 4x minus 3 equals 0, and we need to solve for x. We can do this by completing the square, which would create a perfect square trinomial in the form of a plus b squared or a minus b squared. We can complete the square to solve for x, but there are a few things that we should check beforehand. First, we should make sure that we're in standard form, and that is ax squared plus bx plus c equals 0, and we are. We should also see if the leading coefficient, the a value, in front of x squared is a 1, which it is. Otherwise, we would want to factor it out first. And we should check to see if this trinomial can already be factored. If so, we would need factors of -3 that add up to a +4. And since none exist, we know this cannot be factored normally. Instead of using the lengthy quadratic formula, we can now complete the square to solve for x more quickly. The first two terms will remain the same. So that will be x squared plus 4x plus a new third term that we're going to introduce. I'm going to leave a blank so I don't forget. And then we're going to move the third term to the other side. So adding 3 to both sides would create a 3 on this side. And if we're adding something to one side, we have to do it to the other as well. So we'll use another placeholder. The new term that we're going to introduce is going to be b over 2 squared. In this case, our b value is the coefficient of x, and that's 4. So we'll have x squared plus 4x plus, and then the new term, b over 2. 4 divided by 2 is just 2, and that will be squared, equals 3 plus the same 2 squared. The 2 squared could be simplified to 4, but I'm leaving it in this form for a trick to help quickly factor this trinomial. So when we have a perfect square trinomial, the factored version will first have an x, that was our first term, and then we're going to either add or subtract, depending on the sign, the b over 2, not the square, just the b over 2, which is a +2 in this case. So it's this number that will be right here. We have x plus 2, everything squared, equals, and on this side we have 3 plus 2 squared. We know 2 squared is 4, so this all equals +7. Now, in order to get the x out of the parentheses, we need to square root both sides, keeping in mind that this will be a positive or negative value on the right side. So if we square root something being squared, those cancel, and we're left with just x plus 2 is equal to positive or negative square root of 7. Now all we need to do is move the 2 over. So we get x is equal to -2 plus or minus the square root of 7. And if your teacher prefers, you can split these up into the two answers that they are, which is x equals -2 plus the square root of 7, comma, our second one would be -2 minus square root of 7. So these are the two values for x that solve the original quadratic, which are also known as the roots, and also the x-intercepts of the parabola created by that quadratic. Let's try this one. We have x squared plus 3x plus 1 equals 0. We'll do the same checks first. We are in standard form. The coefficient in front of x squared is 1, so we don't need to factor anything out. And this trinomial cannot be factored as it is. So we can begin completing the square. We have x squared plus 3x plus the new term that we're going to include. Move the 1 over to the other side, equals -1, plus that same new term. Again, that third term is going to be b divided by 2 squared. We need that on both sides. Now in this case, our b value is a 3, which is not even, but that's okay. We can still use the same rules to complete the square. So we have x squared plus 3x plus b over 2 is simply just 3 over 2 squared equals -1 plus the same new term, 3 over 2 squared. Now we have a perfect square trinomial, so we can go ahead and factor. We know the first term is going to be the x. Our second term is going to be the positive 3 over 2. That goes right here. So x plus 3/2 squared is equal to -1 plus, and we'll simplify. 3 over 2 squared would be 3 over 2 times itself, and that would become 9 over 4. Before we square root both sides, we should simplify the right side over here. To combine the right side, we're going to multiply -1 by 4 over 4, so we can combine the fractions. We'll get -4 over 4 plus 9 over 4. And that's going to equal 5 over 4. Now we have x plus 3 over 2 squared is equal to 5 over 4. We need to solve for x, so we'll have to square root both sides. The right side is going to be plus or minus. That leaves us with x plus 3 over 2 is equal to positive or negative square root of 5 over 4. And we can simplify the root 5 over 4 real fast. Since that's equivalent to the square root of 5 over the square root of 4, that means that the fraction really is square root of 5 over 2. And it's still positive or negative. At this point, we now have x plus 3 over 2 is equal to positive or negative root 5 over 2. And we just need to subtract the 3 halves from both sides. X equals negative 3 over 2 plus square root of 5 over 2, comma, and the other one would be minus. So negative 3 over 2 minus the square root of 5 over 2. Now what if we have 3x squared plus 12x minus 2 equals 0? While we are still in standard form, I'm sure you noticed that the coefficient in front of x squared is no longer a 1, we have a 3. But before we factor out the 3 from this trinomial, notice that the third term is not divisible by 3 evenly. So while you could factor out the 3 right now, I would suggest moving the 2 to the other side so we don't have a 2/3 to deal with at the moment. Moving that over, we have 3x squared plus 12x equals positive 2. At this point, we want to factor out the 3 from the left side, which would leave us with 3 times x squared plus 4x. And here's where we're going to introduce the extra third term, which is the b over 2 squared. On the other side, we still have 2 plus, and here we have to be careful. The new term is not just b over 2 squared, because if you notice, the 3 is on the outside of this entire parentheses, meaning that we're not really adding a b over 2 squared to the left side. It's b over 2 squared, then times 3. So really, the new term is 3 times b over 2 squared. We have 3 times x squared plus 4x plus b over 2, that would be 4 divided by 2, so that's 2 and then squared, is equal to 2 plus 3 times the 2 squared. Because again, if we take 2 squared out of this parentheses, it's going to multiply by the 3, so we have to account for that on this side. We'll leave the 3 on the outside and factor. First term will be x. Second term is the b over 2, which is just 2. That goes here. So we have x plus 2 squared equals 2 plus 3 times 2 squared is 4. We'll simplify the right side real fast. 3 times 4 is 12 plus 2. So this is going to give us 14. Now we have 3 times x plus 2 squared is equal to 14. Before we square root, we need to divide the 3 away. So we'll do that from both sides. Divide by 3. Now, x plus 2 squared is equal to 14 over 3. And now we can square root both sides. It's still plus or minus on the right. And get x plus 2 is equal to plus or minus the square root of 14 over 3. Subtracting the 2 from both sides gives us x equals negative 2 plus or minus the square root of 14 over 3. But we can't leave it like this because there's a square root in the denominator. The root 14 over 3 is equivalent to square root of 14 over the square root of 3. So we need to rationalize the denominator. And we can do that by multiplying the top and bottom by that same value, the square root of 3. So now we have root 14 times root 3 would be the square root of 14 times 3, which is 42, over square root of 3 times square root of 3 would give us square root of 9, which simplifies to 3. So our final result is x equals negative 2 plus the square root of 42 over 3, comma, negative 2 minus the square root of 42 over 3. Let's look at one more very important example. Say we have negative 6x plus 2x squared plus 10 equals 0. You've probably noticed that this is not in standard form, so we'll first do that. The 2x squared needs to come first. 2x squared minus 6x plus 10 equals 0. Now we'll want to factor out the 2, so our leading coefficient would be 1. And even though the c term 10 is divisible by 2, I suggest moving it over first to keep things a lot simpler when we complete the square. So we have 2x squared minus 6x equals negative 10. We'll factor the 2 out and make room for the new third term. 2 times x squared minus 3x plus the new third term. And the reason I'm always writing plus is because this third term, no matter what it is, it gets squared, which always makes it positive. So we have the b over 2 squared equals negative 10 plus, again, be careful, the new third term is b over 2 squared times the 2 on the outside. So really, it's 2 times b over 2 squared. We have 2x squared minus 3x plus our b term is negative 3. So this becomes negative 3 over 2 squared equals negative 10 plus 2 times the negative 3 over 2 squared. We'll factor inside this parentheses 2 times the first term x plus the b over 2 term. But be careful, this time b over 2 itself, without the square, is a negative. So what that means is when we introduce it here, it's going to be minus 3 over 2 squared equals negative 10 plus negative 3 over 2 squared would be 9 over 4 times 2 gives us 18 over 4. Let's simplify the right side. We need negative 10 to have a 4 in its denominator, so we can multiply it by 4 over 4, which gives us negative 40 over 4 plus 18 over 4, and that leaves us with negative 22 over 4. And we can simplify that further, dividing numerator and denominator by 2, and that leaves us with negative 11 over 2. So we have 2 times x minus 3 over 2 squared equals negative 11 over 2. We need to divide both sides by 2. And on this side, since we have a fraction, instead of dividing by 2, I would rather multiply by the reciprocal, which would be times 1/2. Same thing as dividing by 2. Here we have x minus 3 over 2 squared is equal to negative 11 over 4. We need to square root both sides. This is plus or minus. Now, x minus 3 over 2 is equal to plus or minus the square root of negative 11 over 4. You may have noticed that we have a negative inside the square root here. So if you have not covered imaginary numbers, which is I, that is equal to the square root of negative 1, then your answer would stop here and there would be no solution, or more accurately, no real roots, implying that there are imaginary roots. Chances are, if you have not covered imaginary numbers, you will very soon. So we're going to continue so we can complete this problem and you can see what the final result would look like. The square root of negative 11 over 4 can be simplified to the square root of negative 11 over the square root of 4, which would be the square root of negative 11 over 2. And if I is equivalent to the square root of negative 1, imagine we factored out a negative 1 from the negative 11. In other words, the square root of negative 11 is equivalent to the square root of negative 1 times the square root of 11. And now we just need to replace the square root of negative 1 with an I. So this is really equivalent to the square root of 11 times I. And we still had over 2. So now on the left side, we just had x minus 3 over 2 is equal to plus or minus the square root of 11 times I over 2. We just need to add 3/2 to both sides. And we get the final result. X is equal to 3 over 2 plus or minus, and you can separate them if you'd like, the square root of 11 times I over 2. If you're curious what an imaginary root means, real roots give you the x-intercepts of a quadratic. So in other words, if we had a quadratic that looked like this, here's one real root, and here's the other real root. However, it's possible to have a parabola that never crosses the x-axis. Maybe it looks like this. And in this case, since we do not cross the x-axis, there are no real roots, only imaginary ones. Now that you know how to complete the square, check out this video on graphing quadratics in vertex form. The vertex form can be made by completing the square.